Cool. Well, we're going to go ahead and kick off our programming today with Paul.
I assume this is my mic. Can everyone hear me okay? I want to lean into this thing. All right, so if I could kick over the slides. Thanks everyone for coming by, waking up early, hopefully not partying too hard last night. So given the topic of this conference and what everyone's building in the privacy space, I thought I wanted to talk about how we get privacy generally adopted. How do we get people using it? Especially considering that we've been trying to build privacy tools for decades, and many of the tools have failed adoption. Some have succeeded. So my goal is to kind of go back in history and look at the different privacy tools, protocols, technologies, and see and analyze what we think might have been their kind of good decisions or missteps, and hopefully learn from that, especially for everyone out here who happens to be a builder, to really help build the tools and technology that get not just interesting from the viewpoint of what privacy can deliver, but to make sure it actually gets adopted and delivered to the masses. So quick introduction, my name is Paul Puey. I'm CEO and co-founder of Edge. We're a self-custody, multi-platform trading app for cryptocurrency. Former senior engineer over at Nvidia back before AI was even a thing, or what was called. Been in the crypto space since about 2014, now running on about 11 years, and spoken at a few dozen conferences in that period of time. Can't say I know everything about crypto, for sure. I don't think anyone does. The thing I've noticed is as the years go by, the industry grows faster than anyone can actually learn it. So I feel like I know less and less every single year, but try to give insights on what I've seen over time. So going into history of privacy technology, let's start with stuff that's not even cryptocurrency, just encryption, which is obviously the core of what delivers privacy. And so doing a little case study of PGP. PGP, or pretty good privacy, was a technology invented in 1991 by Phil Zimmerman. And it was a technology that allowed you to both sign and encrypt messages or data. It was primarily targeted for email use, right? For us to actually be able to sign to verify that a message that we sent was created by us, and then also to encrypt that message so that obviously the recipient could decrypt and see it and no one else. It had plugins for various email clients. Outlook was fairly ubiquitous at that time. Thunderbird, Eudora, if anyone remembers that era, back when Qualcomm was barely a chip company. They actually made email software, and then like MacMail. But in 1999, the fifth version of PGP, PGP5, was analyzed by some researchers, and they looked at the usability and tried to see, how usable was PGP5? And they analyzed it using two different techniques. One was basically just a walkthrough and looking at the different steps needed and pretending that you're a beginner or someone not familiar. It's kind of what we try to do is, when you're inside the bubble of cryptocurrency and you analyze your own product, you pretend that you don't know. So that's the best you can do. And then they also took true laboratory user survey and studies, asking people to walk through the process of, creating keys, signing email messages using PGP, encrypting messages, decrypting them. And at the end, they really gave a good analysis of everything from the visual metaphors used, such as these icons, to the types of keys and the challenges that people had deciphering the kinds of keys, the key sharing, and backup and security of keys, which we can definitely attest to in this world of crypto. They analyzed things such, these visual metaphors as an example, these buttons that showed keys, encrypt, and sign. And some of the challenges that they noticed were the analogies to the real world of keys kind of break down, because in encryption you have public and private. And in the real world you just have a key, right? It unlocks, it locks, and it unlocks. There's not a concept of this public versus a private key in the real world. In decrypting, there's no key on the icon, but you need a key to decrypt. So these little subtle visual metaphors really broke down for a lot of people with their study. And at the end, their summary was, it was a complete failure. This was a fully, by and large, unusable both app and protocol. And the summary was they took about one third of the people that they had passed through the test could not successfully sign and encrypt an email message given 90 minutes. 90 whole minutes, that's an hour and a half, and they could not successfully do it. That's, what was it actually? Yeah, one third of them. Only one third could do it, 2/3 could not. And so an example of what I would say is definitely not what to build when you want to get mass adopted software. One of the challenges, I know I had looked into this paper, was actually the key sharing, not the private key, but the public key. How do we properly get the key from sender to recipient, discovery of the key servers, and that's something that will go into newer technology and how that newer technology solves and helps with adoption. But key sharing was easily one of the biggest challenges that people had. Let's go to another technology, good old SSL and HTTP, invented in 1989 by Tim Berners-Lee. We had finally the web and browsers. Prefixed with HTTP, everything was in the clear. Every piece of traffic could be seen by every server that happened to be in the middle of the hops to go from sender and recipient. Come 1994, though, we introduced SSL, or HTTPS, as you'd see, which now exists today. First implemented, I believe, by Netscape. And then looking into today, that little snippet at the very bottom is actually a clip from the government's website saying, use SSL, use encryption. Everything should be considered sensitive. Not something that we would have expected the government to do, given that they were trying to clamp down on any kind of encryption at the time. Now they effectively mandate it. SSL, by and large, I would consider to be a successful deployment of encryption. It came with trade-offs, especially in that public key discovery. We have certificate servers that are, in essence, somewhat of trusted entities that we go to determine, is this truly the public key of a server that we're going to be communicating with? And while we have that compromise, we've distributed that trust across many different certificate authorities. And so the benefit is, it's automatic. You go to a browser, you punch in a URL, you're done. There is no key management, there's no encrypt and sign, there's no, it's impossible to get it wrong. And that's kind of the beauty. And there are now even newer domains that mandate SSL. If you ever say .app domain, you punch that into the browser now knows rules that say this cannot be non-SSL, this has to be SSL. So looking at this protocol, I would say this is the shining example of one that took, what I'd argue are the good alternatives in compromises of privacy versus usability. Now getting into some of our favorite things, chat apps. I'm going to analyze a handful of different chat apps and where they've kind of gone right and gone wrong. So Telegram, ubiquitous in the cryptocurrency world. What did they do wrong with respect to getting privacy adopted? Number one, it's optional privacy. You have to specifically create an encrypted chat, or what they call a secret chat, with people. All right. So by default, nothing is encrypted in Telegram. If anyone told you Telegram was a private chat app, they were wrong. All right. By and large, unencrypted. Every chat that you do that is encrypted creates a different key pair. So you could find yourself chatting with the same person and have multiple chats that are individually encrypted, and it'll appear in the app as two different chats with the same person. You're like, well, why are my chats confused? And they arbitrarily target different devices. So if you have Telegram on multiple devices, when someone tries to send you a secret message, it finds one of them shares keys with that one specific device, and that's where you chat. So I'd find that Telegram on my iPad and on my computer, on my phone, when someone sent me a message, I wouldn't know which device it would go to. Very, very bizarre user experience. What do they do right? In my opinion, nothing. This is a complete failure for adoption of privacy because no one's using the actual privacy protocol that Telegram has. From an adoption point of view, they've got 800 million active users, and privacy near 0% at this point are using the privacy portion of Telegram. And I think this starts to veer into one of the biggest challenges of privacy is when it becomes optional. So WhatsApp, what do they do right? From the viewpoint of discovery, that key management part, they made phone number discovery an easy way to find someone. There are a few other chat apps in the past that didn't do this. You had to find handles and share keys. This one, simple phone number discovery at the compromise of, even though chats are encrypted, you do know which phone numbers are talking to which other phone numbers. So that is a compromise, but realize that they did allow for people to get encrypted chat almost invisibly. It's encryption by default. So contrary to Telegram, you're always using end-to-end encrypted chats. But what did they get wrong? Single mobile device use, this is a small little gripe I have. I can't have an Android and iPhone. Both have WhatsApp on it for whatever bizarre reason. Seemed like an arbitrary limitation, which try to avoid bizarre limitations like that. Doesn't make any sense. But their biggest flaw was that WhatsApp automatically backs up your chats to Google Drive, if you're on Android, if you have that, and iCloud on an iPhone, and those are not encrypted by default. So what's the whole point of this beautiful end-to-end encryption when two of the biggest companies in the world will effectively have copies of your entire chat history unencrypted? And so while they've got a huge amount of adoption with 2 billion monthly active users, the privacy, I'm going to ballpark based on anecdotal asking of people, how many people don't have iCloud active on their phone or Google Drive. Probably less than 10% of people don't have that. So you're not getting quite the adoption that you'd like. So less than 10%, maybe 5%. So instead of 2 billion, maybe 200, maybe 100 million people might actually have the benefit of privacy. And the problem is, you might not have your chats backed up, but the people you talk to might. And therefore, you've exposed your chats through someone else. iMessage, I gave credit to Apple as being one of the few companies that really mass deployed end-to-end encrypted chat. And they did it for a lot of people that care nothing about privacy. And so similar to WhatsApp encryption by default, phone number discovery, as well as email discovery through iCloud, they did that right. What they did wrong, iOS only. So iOS and Mac, you're really limited there. As soon as you chat with, for those of us that have iPhones, you chat with an Android friend, your green bubble friends, you're going over SMS, which is probably the worst of all from a privacy point of view. And they have very similar flaw as WhatsApp. They back up by default everything into iCloud unencrypted. That has partially changed with newer versions of iOS, like 16.2 and above, where you could encrypt your backup, but it's extra steps that you have to look up online on how to do. So another example of this was a great opportunity to drive massive adoption of a privacy tool, but failed because, Apple basically sees all of the backed up messages. And with 1.3 billion active, once again, a guesstimate of less than 10% of that, we've lost a huge amount of potential adoption. And I think a lot of the privacy advocates' favorite, Signal. What do they do right? Phone number discovery, obviously encryption. By default, you cannot send a message that's not encrypted. They've recently added user handles, which helps a lot on privacy because you no longer have to expose a phone number to that other user that you're chatting with. And what they did wrong, small little gripe, the synchronization of chat history. So when you switch devices is a complete mess. You basically lose chat history by and large when you switch devices, especially going from phone to desktop to iPad. But there is no unencrypted backup. You would have to manually go through the trouble of trying to back up your chat history, which isn't even possible on certain types of devices. So it's kind of harder to mess up, even though it's inconvenient that you don't have this backup. Unfortunately, it's just a much smaller user base, at about 4 million total, not active, but 4 million total as of 2021. Hopefully that's much larger now. But all of those people get close to 100% privacy. So let's look at cryptocurrency protocols. Look at two of the most popular that are trying to drive privacy, Zcash and Monero. Starting with Zcash, what do they get right? Biggest one is the cryptography. These are some of the smartest cryptographers in the world working on this protocol. the anonymity set baked in to the protocol is everyone that is using their private Z addresses, as opposed to trying to mix with a handful of inputs and outputs. But what they got wrong is, once again, similar to PGP, they got wrong optional privacy, meaning by default, what are people using are the transparent addresses. And another gripe is synchronization performance. It takes a very long time to discover which transactions are yours. From an adoption point of view, in 2020, only about 6% of the transactions broadcast were actually shielded. And a study by Carnegie Mellon showed that about 99+% of the transactions could be traced. And so it shows that even though you might have a really, really good technology, if you don't have more people inside of your pool of private transactions or private communications, you stick out like a sore thumb and therefore increase by a large margin the traceability. And I like to say, if you're in a room of people, you're the only one with a mask on your head, and everyone, the entire kind of head count of who's here, you'll know who is hiding. And the same model happens in crypto tools. And so the adoption curve, unfortunately, of Zcash, which I think there's still hope, right? That it's a smart team, they know what they're doing, but really trying to drive that default privacy is kind of, without that, you've really leveled the amount of adoption, and I think the people who do care about privacy are not quite using it yet. That strong cryptography needs to be paired with more of that default privacy. Then in contrast, Monero, what did they do right? Privacy by default. It didn't start that way. It had definitely poor privacy early on until about 2017. But now it's by default with about what they call a mix, a ring signature of about 10, which gives pretty good privacy. A fast sync option, so once again, that performance issue I was mentioning. The MyMonero API allows people to effectively sync their transactions with a bit of a privacy compromise, but with a huge performance improvement. What do they do wrong? Much weaker cryptography. So the cryptography in MyMonero does not use ZK snarks, instead ring signatures, which is effectively hiding your inputs and outputs within 9 other decoy inputs and outputs. But ironically, because the anonymity set is so much larger, because all the transactions are shielded effectively, the same researchers from Carnegie Mellon had determined that recent transactions, in all of history, about 80% of the transactions are by and large untraceable, with the recent ones being almost 99% untraceable. And so the weaker technology, but with a very high level of adoption across many more people and many more transactions, actually equated to a higher level of privacy. So adoption is key in that sense, not just because we want people using it, but for the people that care about privacy, getting more people adopted into our pool helps give it to us as well. And that shows in their adoption curve. So the traceability, this is a traceability graph, and the traceability dropped off a cliff, which is a good thing, as soon as they had adopted some additional technologies, such as ring signatures and increasing the ring signature size to about 10. And the adoption curve has kind of grown with it. These are the number of transactions, the red line, number of transactions on the network over time. And I think we see that people that do care about privacy are adopting this, adopting Monero nicely. And so in summary, right, what do we have to take away from some of the study is make privacy hidden, is what I like to say. We use privacy to be hidden. Well, privacy itself likes to be hidden. Hide it from the users. Don't make them go through any extra effort to get it. Otherwise, you'll only get really kind of the illicit actors and the people that care, which means we get lumped in that same group. We don't want the people that care about privacy to be lumped into illicit actors. In a way, that's somewhat what happened with Tornado Cash. It didn't have enough usability and seamless invisibility to get the masses using it. Make privacy default, and then don't actually make a backdoor, right? Like that backdoor with a backup. You don't want one. You didn't intend to do one, but suddenly you gave it one. So you don't weaken it for no good reason. And then anecdotal requirement from our experience having deployed many privacy protocols is make it performant. In our experience, when Monero didn't have bulletproofs, it took about 45 seconds to sign a transaction. We easily skyrocketed our tickets, our support tickets, because people would say, well, what's taking so long? And they'd give up and they'd close the app. In the same sense, when it takes a long time to synchronize, tickets shoot up the roof, and then people just stop using the protocol. The MyMonero API for Monero did definitely improve that. So learning to keep things performant and with an interactability is a pretty key thing. And that is it. Thanks for listening. If you ever want to get in touch, @Pollinator is my Twitter handle, edge.app. You can find me there as well. We do support multiple privacy protocols. You see on here Pirate Chain, Monero, and Zcash. That's where we help learn a lot of what it takes to get these things adopted, and we get feedback from users, which is helpful. I'd love to hear feedback from you guys as well. So thanks, everyone.
Great. Awesome. Thank you so much. We have a couple questions from Slido that if you'd like to take some questions.
Absolutely.
Cool.
Mic check.
So the first, and everyone remember Slido.com. We've got it right here. Ask your questions. So the first one we have here is, what was the peak of adoption in Zcash in summer 2022? Was it Tornado Cash related?
So because it's private, it's hard to tell, right? So that was I'll go back that slide. That huge peak right there. You'll notice that was one of the times when the red bar was almost 50% of the total transaction volume, as opposed to 6%, which is what it had been in the past and today. And so there's believed to have been a spam attack, unfortunately, as opposed to there being real transaction volume. But in all honesty, it's hard to tell. They were encrypted and shielded. So unknown,
Good
but
answer.
believed to be a spam attack, which definitely slowed down the network, made it take days to synchronize a wallet, right, to discover your transactions. And with that, a huge drop in effectively real usage of the network by at least people that we were aware of.
And so we've got another great question here. What did Monero do that Zcash could learn from, adoption-wise?
The two things that I'd mentioned, which is privacy by default, is one of the big ones. Don't make privacy an extra step. Make transparency an extra step. A lot of the criticisms of privacy by default are like, oh, but maybe I want to be transparent because I'm a nonprofit and I want to be able to show what funds we're getting and receiving. That's easily possible. You can share a key that can decrypt all the transactions that you receive. Doesn't mean it needs to be the default. And so that's one thing Monero did. I think that all the privacy protocols honestly should do, is allow for transparency, but don't make it the default. And then second, the protocol where a view key is given up and it compromises some privacy, but at a huge usability and performance increase. Those are probably the two biggest things that I would say any privacy protocol should learn from the viewpoint of adoption.
Awesome. Thank you so much.
All right, thanks everyone.